recorded, so I think she might be interested.
Yeah, we're gonna. What the speaker can do is screen capture, and then Lex has the audio. And you get to sync it. I am perfect person.
Stand there or just nice.
And then.
You know, I often like to roam around here, but I don't think I'm going to this time. So I think I'm good.
Full production.
And actually,
Nice.
I can respond voicing without the mic, so I think I'm good. Thank you, though.
In the past, we just contracted that, but that's super expensive.
Oh, yeah.
You know, and the quality is you average with that. So here we go. GIS Pro. I know that's our GIS Online. Yeah, I do too. It's been, you know, like we're getting money with. Thanks for getting automatic reboots.
Yeah, they have a way of sending these things out.
It's horrible.
And I know it's to be called universal destinations. You can tell when somebody's secretly working with your machine, you know, through that, because everything grinds to a halt. Everything slows down.
You can just
Push that back.
No, I haven't seen any sort of awareness of when the machine is being actually used, or limits itself to only data against.
yeah. So now you have to set up for, well, yeah, no, I'm sorry. Once you hit that point, you'll give it a few seconds. And then
Search for stuff. That's the only thing I'm concerned about is I'm jumping between several categories. I haven't done this. I used Camtasia, but I haven't used
resources.
Yeah. Not so much Camtasia.
Exactly.
And the alternative, but it's truly it's like a big data. Somebody's going to write some scripts to go around the table.
You have to do that, or a bunch of quiet, and if there's any feeling like, this doesn't feel good, then just tell it.
He's actually written some scripts.
It's muted again. It's muted
Oh,
again.
have you started it?
I started it, but
It's a song.
but I don't know, there's no sound. Dev guy's over there and watching, so
And then we'll just
see if you can get sound.
Oh, I think I just need to do this. No, that's right.
Is it muted? For some reason that.
Yeah, I'll go check it out.
Yeah, go check and see if some of the sound out.
Yeah, I found a job to do that.
It's probably, for me, it sounds. We'll see. It's running. Yeah, I just started. I normally do like that. I got too many things happening here. Straight from the mouse.
Oh, okay. Testing on the mic. Does that sound like it's working? And how about the humans in the room? Can you all hear me okay? That's usually not a problem for me.
Faye, can you help get people in? Just tell people outside. Oh, sorry. When you turn them, you start tapping during your conversation. Just start introducing.
Hang on just a second.
Okay. Hello, everyone. I hope the coffee gave us all of us some more energy. My name is Wendy Guan from the Center for Geographic Analysis. It's my honor to introduce our next speaker, Cody Benjamin from ESRI. He's the technical product manager for Esri's imagery team.
Correct.
And has over 20 years of experience in working in remote sensing and GIS, and recently focusing on UAV imagery processing. So I wouldn't read his bio that you all have in here. He has tons of experience and products. But I will mention that he is also a proud Harvard parent.
Oh.
His son is in our college, class 2020. So with that.
Thank you, Wendy. Actually, I was not going to mention that. But anyway, thank you very much. I appreciate the opportunity to speak here. It's an honor. What else can I say? You may not have heard this new catchphrase from Esri, but I hope you'll be hearing it a lot more, and maybe the people you buy groceries from and buy gasoline from will start to know Esri as the science of where. And what I'd like to do today is talk about where drone imagery gets applied. So the specific topic is drone imagery within the ArcGIS platform, and without further ado, let me go ahead and get started. Many of you, if you've been to the Esri user conference or any of our presentations, you've seen some of these sort of slides. So what I want to do is start with just the context of the way we look at the overall imagery the imagery component of the ArcGIS platform. Our data model for managing and sharing imagery within ArcGIS allows virtually unlimited imagery content, so we can rapidly access and then on demand or as necessary, process that imagery and provide a very robust data management solution. I assume you also know that Esri or that ArcGIS has a lot of different spatial analytic tools for working with GIS data as well as imagery. We've been working for probably the last 15 years to really make imagery a core component of the ArcGIS platform. And then last, once we've done whatever processing necessary to share imagery, as image services, you're able to access the imagery from its original format, from any map projection going into any map projection, and share that imagery either as what we refer to as dynamic image services or as OGC standards, WMS, WCS format image services are also capable from the ArcGIS platform. So for today's talk, what I want to talk about is how drones fit in with all of this. And when I thought about this tagline or this subtitle, I thought that's really one of the key takeaways. I was asked to talk about drone to map, and I will focus specifically on that. This follows what Jordy had talked about, and I assume is similar to what Thomas will show a little bit later. But there's really a much bigger story here, and that is how drones integrate in various components of the platform. So if we look at the management concept or the management tools, we've got extensive content within ArcGIS Online for assisting project planning. One of the best examples is elevation data. Drones fly so close to the ground, if you want to get consistent resolution, and for that matter, not run into the ground, it's a good idea to know where the ground is. And we've got a worldwide elevation data set within ArcGIS that you can access simply as a dial tone. Of course, there's property parcels, there's political boundaries, et cetera, within the system. We've also got specific processing tools for bringing that imagery in and then working with the imagery. And this is really where I'm going to spend most of the presentation. So bear with me on my context here. On the analysis side, of course, you've got to be able to visualize multispectral data. You've got to be able to go into different map projections, enhance the imagery as necessary. So we've got a lot of visualization capabilities. Spatial analysis, I'm really not even going to go beyond this one line, simply because that's going to depend so critically on what you're doing. If it's vegetation analysis, it's different than if you're doing inspections of transmission towers for a utility. And then, of course, as we get deeper into analysis, you'll see this is actually one of the newer features from Esri and ArcGIS, is the ability to scale up our analytics in a cloud environment to process very, very massive data sets in a very short order. And again, I'm not going to spend any more time on that, but that's something you'll hear about this year at the user conference or through other venues from Esri. So again, once we've gotten imagery into the system, we can share as what we call dynamic image services. And I often do a show of hands. I'm not going to do that at this point, but if you're not familiar with what we call the Mosaic data set, it's our database model for managing and accessing imagery. And I do have one other slide on that. But coming out of that, we can share what we call dynamic image services. And the dynamic component means if you've got overlapping imagery, you don't have to throw away one image or the other. You can have both images, bring either one to the foreground. You can also apply processing on the fly, and I will talk a little bit more about that. We're also seeing a lot of utilization now of geoprocessing services. And this is where you've got a server running and it's got the data, but you don't want to download large volumes of data to your client, so you actually invoke a task on the server. And the simplest example I can provide would be something such as a downstream trace. If you want to calculate where water will flow from one point downstream, in the old days, meaning just a few years ago, you had to have the data on your computer, you had to have the processing power, and now with geoprocessing services, a very lightweight client can click a point on a map, which is really all you need to tell the system, this is my starting point. The server has the elevation data and the processing power. It returns a very lightweight feature class back to you as a result, all this being done in the cloud. Anyway, bear with me. I didn't mean to spend quite so much time on this intro. Of course, we've got APIs for our partner companies and customers who want to build on the ArcGIS platform. And another very important component is we've got built-in security. So, for example, many classes of our clients don't want their imagery being shared with the world, and we've got a very good set of security tools within ArcGIS. So for me, again, one of the key takeaways or one of the key revelations was to realize that drones, in the most abstract sense, are really nothing more than mobile sensors that are continuously generating geospatial data and critically depend on taking in geospatial data, consuming that data to do their job. And I'm encouraging my colleagues to not think about drones as quadcopters and fixed wing, but also mobile vehicles that are on the ground, ROVs in the ocean or in lakes, perhaps something shaped like a snake that will find its way down into a collapsed building after an earthquake and find survivors. These are all different kinds of drones, all different kinds of geospatial data. And part of my goal is to bring all of that into the ArcGIS platform so people can get access to that data and use it when they need it. Okay, that was my context. So let me get into a little bit more of the detail. What I really want to focus on is getting that data into ArcGIS and then making it accessible. So I want to talk, I'll focus a good part of this on drone to map, but we've also got an add-in called the full motion video, or FMV add-in, that allows us to look at video data in a map context. And ortho mapping is actually fairly new, and that's bringing some of the drone to map or single frame image photogrammetry into the ArcGIS desktop as the platform. So one of the things I learned as my phone started to ring the last year and a half and people said, can I get my drone imagery into ArcGIS? I finally learned not to take 5 or 10 minutes to ask the question, what sort of imagery are you shooting? Because the workflow is going to depend on how you're collecting data and what sort of sensor you've got. If we're shooting nadir imagery and doing 2D mapping, the workflow is different than if you're orbiting around a building and shooting oblique imagery and want to build a 3D model. I'm also seeing a great deal of interest, or a great deal of activity actually, from primarily utility and petroleum industry for doing close range inspection with drones. And one of the differences, of course, is the standoff distance. If you're mapping or doing obliques, you're probably several hundred feet above the ground. For the close range imagery, we're talking of just 5 or 10 meters from your subject. But the other component that's very critical is that high oblique angle. With our history of being a mapping software product, we naturally assumed you wouldn't be interested in any imagery unless it's on the ground. But if you're flying up next to a transmission tower and in the background you see the horizon, that didn't just automatically come into ArcGIS easily. So this is where we've been working on some other aspects. And again, this is not specifically about drone to map. And of course, there is also full motion video, typically taken at an oblique angle. Again, we can bring this into ArcGIS, but it is fundamentally a different workflow. So looking specifically at drone to map, you'll see the workflows or the options within drone to map reflect the different modes I was just referring to. So we do have a rapid mode, which is what I'll actually show, but that's really just for field QC. But the standard output products are to generate 2D orthorectified mosaics and a digital surface model that comes with that. In the 3D oblique mode, we're generating point clouds and a 3D textured mesh. And then if we're in that inspection mode, it's primarily a data management scenario where we just want to be able to get to the right photo quickly and easily, but we're not trying to take a high oblique image of a transmission tower and put it on the ground. So I think that was all I needed to say about that. I guess the one last thing I did that I think is very important, you'll find I'm not really a salesman. I see my role as helping our users get the best use out of ArcGIS possible. I love it when people are using drone to map, and I'm very glad we have drone to map. But we also there are many other very good software products out there that can do similar work. Drone Deploy will do this processing in the cloud. Pix4D, Jordy showed some of their software on screen. We're actually in partnership with Pix4D, and the Open Drone Map is an open source tool set that you'll hear about after my talk. The bottom line is I don't want to get stuck in a rut and say you have to do everything with Esri. If you're using any of these other tools, we can still bring that data into ArcGIS. So enough PowerPoint for now. Let me jump out and actually show you what drone to map looks like. And again, I don't want to turn this into an extended demo, but I do want to show you some of the basic features of the software. This is what you'll see when you start drone to map. You do need an ArcGIS Online subscription account to run the software, but we do have in the licensing tab, we've got the ability to check it out and take it offline. Out in the field, what you'll want to do is a rapid process to just verify you've covered your project area. You can also do 2D mapping, 3D mapping, or inspection as different modes. But I'd like to go ahead and do a rapid project very quickly just to show you what this looks like. We've got some data provided to us by a company by the name of GeoQ, a subsidiary named Ergon. I just want to give them acknowledgement for this data because it's really very, very nice data. What I'm doing is just telling the software what the name of the project should be and where to store the project. But then if I want to add the imagery, it's in my asphalt plant folder under photos, and I'm only going to do a small subset. So in this case, we've got GPS data in the header of each image file. If you didn't have that, if GPS is in an external file, you can read that file in. But those are really the steps to getting a project started. And once the software finds those images, it basically gives me an immediate view of the project area. Let me go ahead and start this just to get this processing in the background. Another feature I really like about Drone to Map is how responsive it is, so I can continue to do my demo even while the processing is running. And I wanted to switch base maps just to eliminate any confusion. When you saw imagery come up immediately, that wasn't the drone imagery. That was my base map, the Esri imagery base map. Let me try a different one and look at our streets base map. Well, there's just not much detail. This is an asphalt plane. Okay, so while I'm waiting for the software to process, we can do a quick QC by looking at each individual photo. And when you're out in the field, it's very important to make sure you don't have excessive blurring, or if you thought you were shooting nadir and all the images looked like they were oblique because it was so windy, those are some of the good QC checks to perform in the field. But let me show you the processing options and just highlight some of the differences between these modes. When I'm in this rapid processing mode, you'll see there's nothing under the dense section, but in the initial processing, I'm processing key points. I think Jordy mentioned the word key points, where the software is finding what in other tools has been called an interesting point, where there's contrast, where the software can actually find something of interest. We're doing that at a reduced resolution, and if the software is having a little bit of trouble understanding your flight pattern, we've got some controls for adjusting that flight pattern. The dense matching, again, I'm not doing in rapid mode, but this is to increase the resolution of the point cloud that would be generated internal to the software. And the default is a minimum of 3 points. I don't know if you can read these numbers on screen, but we can change some of these settings. The basic products that you get out are the Ortho Mosaic, which is the imagery. The digital surface model is built internal to the software as part of the ad hoc photogrammetric process to actually orient and stitch the images together. And then in the latest model of the latest version of the software, we've also added an attempt to take the digital surface model and strip off anything above ground and give you a bare earth DTM. Now, I told you before, I'm not a salesman, and I will tell you this is not perfect. So don't take this to your city hydrologist and say, here's your bare earth model. It's not that high a quality, but it is a good first estimate at that digital terrain model. We can also create contours. In the 3D products, we can generate LAS format point clouds. The 3D textured mesh can come out in a few different formats. The scene layer package is an Esri term for publishing in ArcGIS Online. And there's actually the ability to do a 3D PDF as well. If you're handing off to someone who does not have GIS, you can give them this PDF file. And then under the resources, this is where I can control the number of CPUs being applied. If I was doing any other real work on my computer, I would turn this down, but by default, it will grab all of your cores and use all the computing power available. So those are a look at some of the processing options. And a couple more things I'd like to point out. One that I think is very important, and I think one of the first two speakers mentioned using ground control points. And you'll notice I did not put any ground control into the rapid process. It's not really required by the software, but I want to encourage everyone to consider it mandatory. You're really not going to be happy with the results if you don't put in at least some ground control. And the best, of course, is if you've got a surveyor out with you and you've got a survey grade GPS and markers on the ground to provide very precise control. But if you don't, we've got the ability to take control points off the Esri base map. And again, these are not going to be centimeter accuracy, but they will get you within about a meter. And very importantly, when you take a control point from the Esri base map, it does hit the world elevation and grab a Z value as well. And that will keep your project from one side or the other from floating up or down. So again, not mandatory in the workflow, but I would encourage, you should always use some kind of ground control. A couple of the other options, one is this publish tile layer button. So if you're familiar with ArcGIS, the format of our base images or our base maps, the technical term is raster tile cache. And it's basically a pre-formatted set of images on predefined boundaries that's just very, very fast to serve. And within, you can bring this imagery into ArcGIS and then make tile cache, but we've made it very simple where you can push one button, log into ArcGIS Online. It will generate the cache, upload to online, and then publish that as an image service. The scene layer button is essentially the same concept for the 3D textured mesh. So these two buttons allow me to take a drone to map project and share it immediately through my ArcGIS Online account. Okay, I was just about to have to stall for time, but it just finished. So this is my my rapid project, and again, this was not done at full resolution, and I didn't count. I think I've got 15 or 20 images. So you can see if I had 500 images, this is going to take more time. But in general, that's not a bad result for waving my hands in front of the crowd at the podium. And again, I think it was Jordy that mentioned just making this simple. And that's really what we've tried to do with Drone to Map, is make it as simple as possible. So I think that was everything I wanted to show in that demo, except I did want to show one other thing. So I mentioned ground control points that I want to encourage you to consider those mandatory. Another that I want to encourage you to consider mandatory is this drawing a clip area for the project. Let me switch to a different project here very quickly. This is another thing I like about Drone to Map, is how quickly things will load. So in concept, it's probably obvious. The clip area says I'm only interested in this area, and if I have some oblique shots, maybe I'm telling the software to ignore that. But the reason I wanted to bring this one up is to show you these images were taken with a GoPro on a 3D robotic solo. And in the background, you've got the horizon, you've got clouds. And the software is not smart enough to know those are clouds and know that it shouldn't spend any time on that. So in addition to clipping your project output, this clip area will also give the software guidance where not to waste its time. So if any of you are using Drone to Map and you do have imagery with an oblique angle like this, it's critically important to use that clip area to limit your processing area. Okay, just want to check my cheat sheet. Oh, I had a feeling I was forgetting something. Since I'm not going to do the publishing of tile cache, I wanted to show you what that looks like. So if I was to publish this 2D cache, let me switch back over to the imagery base map. This will show you a little bit of the context of where we're at in, I think it's Georgia or Alabama. I don't remember exactly where we are. I suppose I could zoom out and find it. But anyway, this is the raster tile cache that was published with that single button. I also generated this 3D scene, and again, it's given the amount of processing time and the amount of input data, I think it's really a pretty amazing capability to now share a 3D scene like this through a simple web browser. And I didn't want to give this out right now, but if anyone's interested, I've got a short URL for both the tile cache and this 3D scene. If you'd like, you can try it on your iPhone or your iPad and see what it looks like there. So, all right, I think that's everything I wanted to show on that demo. So let me now jump back to the PowerPoint slides and continue. If you'll remember this hierarchy I was showing of the different imaging modes, the next mode is full motion video. And before I go on, full motion video is in ArcMap only, but it will be 3D in ArcGIS Pro by the end of this year. And something I did not say about Drone to Map is it is a standalone application. You don't have to have ArcGIS installed. Actually, I forgot to show there is a volume measurement button you may have noticed in that upper right corner. If you do have ArcGIS installed, Drone to Map can reach into the geoprocessing toolbox and do some processing, in particular to calculate volumes of something like those asphalt stockpiles. But let me transition to full motion video. If you're not familiar with our FMV add-in, it's basically to take oriented video and put it onto the map. And so what you see is in the left side of this, you're seeing just a very short track, but we show you the track of the aircraft. We show you the projection of the view angle onto the ground, and then show you that video footprint. In this particular sample, the footprint is so tiny you can't really tell. The video itself, we don't try to project onto the map because it really becomes hard to understand what you're seeing. So that's a separate window. So we can also take feature data and display it in the video window. If you've got feature data and a lot of video files and you want to do a search, there's a search tool within FMV to say, I'm looking for this subject matter. Do I have any video that touches that? And the search will go through the metadata of the video and give you indices to jump to the proper points in the video. You can also extract images out of the video. And again, if you're shooting in a nadir or near nadir oblique mode, this makes sense. If you're really off at an oblique angle, those frames may not have a lot of value if you capture single frames, but you can do that. And I decided I did not want to try running too many different applications and show you a demo of FMV. So what I chose to do as a quick shortcut is just show you a couple of short videos. These are only about 60 seconds each. Here you can see a little bit better that video footprint on the ground, and you can see as the aircraft moves. In this particular case, what I did was I turned on a set of features that outlined the building of the VA hospital. I think this is Cheyenne, Wyoming. And so here I'm simply displaying those features in the video, or in the FMV video. And then that's just about all that's in that one. So that was actually a military grade video system, which has all of the metadata about frame orientation built, or camera orientation built into the video stream. And this one didn't seem to want to run. Here we go. So this is a short video to show you data from the 3D robotic Solo. And again, this was taken with a GoPro camera, but there was some processing done to narrow that wide field of view. If you're working with drone video and you don't have a $100,000 camera on your drone, we have a tool called the Multiplexer that can take a video stream and GPS data and either some sort of orientation sensor, or you can simply estimate the orientation angle and stitch those two together into a video stream that's compatible with the MISB format. And I think that may be the first time I said that. The video format is MISB, which is Motion Industry Standards Board. That is, probably isn't important, and if you do know what it is, then I don't need to explain it. But it has to be, for FMV, it has to be MISB format video, which has that orientation metadata within the video stream. Okay, so if there's time at the end and you want to see more, there's a lot more features in FMV. I can come back to that. And I hope that demo of Drone to Map wasn't too fast, but I want to get back to that larger context and talk about what it takes, what's the best practice, how do we recommend managing all of this within ArcGIS, including some tools for automation and to ensure scalability. Okay, I'm back to one of my boilerplate slides, so I'll try and keep this brief. But if you're not familiar with our Mosaic data set, that's the name we gave to the data structure that is used to manage imagery. And it is a database structure, but I want to make sure it's clear we're not reading gigabytes of pixels into a database. All we're doing is, the first bullet in italics there that says reference the source data. What I mean is, if you've got TIFF files, if you've got JPEG 2000, if it's state plane, if it's UTM, we simply reference those files on disk and build a catalog of that in the Mosaic data set. We also ingest the metadata. If you're working with satellite imagery, there's a lot of metadata that's critically important about not only the camera model to allow us to orthorectify the images on the fly, but also there's in most satellite data streams or satellite scenes, they've got metadata that tells you the angle from the ground to the sun. So we can do vertical measurements and you can do sun angle calculations using the metadata from your satellite scenes. We can also define processing to be applied, and let me go to the next few bullets here. We refer to this as on-the-fly processing. But if you haven't heard about the raster functions that we have within ArcGIS, we can attach a function onto a Mosaic data set or to an image. And the simplest example I can give you is elevation data. Most people don't like to look at a black and white grayscale rendering of elevation. A hillshade is much more user-friendly. And in the old days, if you had an elevation data set, you'd run a geoprocessing tool, put another file on disk and build a hillshade. And before you did that, you had to pick the sun angle and the sun azimuth. We now do that with an on-the-fly raster function. And again, if there's time, I can demo this, but hopefully my hand waving is clear enough. With the hillshade function, as you pan and zoom, the system is generating the hillshade on the fly. And if you choose to change the sun angle or the sun azimuth, you can do that instantaneously. And then when your boss comes down the hall and says, here's the new LiDAR data, you don't have to tear your hair out because now you've got to regenerate your hillshade. If you put the LiDAR data into your Mosaic data set of elevation, the hillshade is already done. Slope is already done. Aspect is already done. If you want to go from orthometric height to ellipsoidal height so you can ortho-rectify those satellite scenes onto your DEM, you can convert from orthometric to ellipsoidal height using raster functions. Anyway, that's probably enough on that. Dynamic mosaicing I'd already mentioned, and that is where I've got overlapping imagery and I don't have to choose which pixels to burn into a permanent mosaic. I can bring any image to the foreground that I'd like to. Okay, and then you can of course access as an image by panning and zooming on the map, or as a catalog you can go into the database and pull out attributes and use those to select your imagery. Okay, so how does this apply to drones? Again, that's a general imagery story. If you've got drone imagery, we can bring drone to map and generate the orthos and the DSMs that I had referred to. And if we're flying, in this case, I'm showing an example of twice a month, we've got those products generated through drone to map. If you push that raster tile cache button, you can share those in a matter of minutes with your colleagues or with the world. And that's a very effective workflow if you're only flying 3 or 4 or 5 drone projects. But what I tell people is if you start scaling up to where your boss likes it, you buy 2 more drones, and by September, you've got several disks sitting on your desk and a couple down the hall, it starts to become a data management challenge. So the good news is I'm not going to leave you with a problem. We do have a recommended solution. What I recommend for drone imagery, or really any collection of imagery, is to put each image collection into its own Mosaic data set and stop at that point and then do your QC. Make sure your coworkers put the proper metadata in, make sure the projection is correct, etc. But then, instead of having a lot of Mosaic data sets, we combine everything into one. And now instead of having a drone project over the LA Coliseum and one in San Diego, I just have one single collection. And if I want to find the LA Coliseum, I just zoom there on the map. And I'll show you that in a moment. I do want to point out two very important footnotes. One is, when I say all data, I don't mean put elevation in with optical imagery. So if you've got elevation data, you'll replicate this structure for elevation. If you've got Landsat and low-res satellite data, you can merge it together, but you probably don't want to put centimeter drone imagery on top of Landsat. But if you're doing hundreds of drone projects, you can manage them in one central collection. Oh, the other key point, and this is out in the weeds, as we say, but if you're using a Mosaic data set, in the center there, I say use the table raster type. There's the default raster type when you add imagery into the Mosaic data set. If you use that method, you'll run into some performance issues because you're putting database tables inside other database tables. So if you use the table raster type, then this will scale to literally millions of records. If you look up landsatlook.com, it's got the metadata and a thumbnail for every Landsat scene ever captured. It's well over 2 million records, and it's one single Mosaic data set. And when you pan and zoom, it will perform, and you'll see to your screen, at least if you've got a good internet connection. Okay, if you've got image server, or if you're sharing on a local area network, your colleagues can then hit that one single repository and get at all of your data. If you've got ArcGIS server, you can share to desktop, web, and mobile clients. You can also drill into the metadata, for example, capture date, and pick out the specific date you're looking for. Okay, I want to get back to one more demo, but there's one other key component here, and Jordy touched on this, or actually a lot of what, it was kind of behind the scenes, I think, in what Jordy was saying, but within the software, such as Pix4D, Drone2Map, etc., we're generating these output products, but internal to the software, we're building that photogrammetric model for each image. And there's great value in that, and that's something I want to come back to, but just to highlight the point of the individual frames are still valuable. They do take up disk space, but you don't want to throw those away. So let me jump back to Chrome and show what this looks like. So once I've got that, once I've got my drone imagery, in a action, if I know where I'm going, let me just zoom to the LA Coliseum. This is a project that we did in LA, and I don't remember the exact resolution, but within this data set, hopefully everybody can see, you can actually tell which seats in the Coliseum are up and down. But this is my LA Coliseum data. But if my boss says, wait a minute, no, I wanted to see the asphalt data set that you demoed. So I can jump and center on that selection. If we want to see if we've got anything outside the United States, I can jump to this banana plantation. If you download our tutorials, this is one of the data sets you'll see. It's a banana processing facility. And if I zoom out to show you where we're located, it's on the west coast of Africa. Here's another one from West Point. This is West Point Military Academy, the rifle range. And the last one I wanted to jump to is a little further down, not the last one, but one that I want to jump to is down around San Diego, or this was actually captured by some colleagues at San Diego State University. All I've been showing you so far are the image data sets. I'm going through a Wi-Fi modem sitting over there. There it is. So again, I've got one image service loaded with the orthorectified mosaics. Of course, I've got my digital surface models in there as well. I'm viewing those as a hillshade. From here, I'd like to jump to a couple of dirt piles, and let me zoom out to show you where we are. This is Berkeley, in Berkeley, California. But if I zoom back into those dirt piles, and with either ArcMap or Drone2Map, we can do volumetric measurements of those piles, which is a fairly common use of drone imagery. But in this case, when this refreshes, what I'd like to show is we've got imagery, in this case, from one date. And if I go to my image display order and reverse the order from which image appears on top, come on and refresh for me. Live demos, I love it. You may have to just trust me. There is another data set. There it is. So I've got two different data sets. Actually, in this case, they flew it 11 times, but I didn't really think you needed to see 11 different examples. Okay, and I think there's something else I'm forgetting here. Yes, this is very important. That last PowerPoint slide. So I'm just about done, and hopefully we'll have a couple moments left for questions. But let me go back to the LA Coliseum, and I'll close this. Another very common application that we're seeing are hearing from insurance companies is flying a drone after a tornado or some other damage to look at their damaged properties. And it can be very effective. I have to be very careful because one of my bosses is in the room, and I don't want to portray a negative, but let me say it as a limitation. With any tool, you have to understand the limitations. If I zoom in and look at this truck, it looks like I've actually got a couple of trucks. There's a phantom image in the middle where it appeared in one image, and then perhaps it parked and got imaged 2 or 3 more times. But anything in motion is not going to necessarily look appropriate in your final mosaic. And the specific subject I want to go back to is this cherry picker, which is a rig for lifting a man or woman up and do dangerous work high up above the ground. Again, at about 4 times your image resolution, I think this mosaic is very effective. But if my boss says, wait a minute, that's centimeter imagery, zoom in and let me take a look at that cherry picker, it's really hard to tell if the tornado came through and damaged it or did not. So this is where I want to go to my single frames, which are managed again in a mosaic data set. And now instead of looking at that blended mosaic where I'm taking imagery from a lot of different perspectives, I'm just focusing on one single image and getting the best possible quality to be able to see as much as possible what the camera really saw. A quick pitch for don't throw away your single frames, manage those as well in a mosaic data set. And I think actually I was about to say that's it, but I realized I've got 1 or 2 more slides. If you're interested in this management concept, this is a link to a script. And again, I can get this link to you if you don't have time to copy it down. It's a link to a script that will take the outputs from drone to map and put them into that managed geodatabase where everything is in one collection. I went ahead and put the second URL up because this is the parent URL. If you go to our image management workflows, you can find the drone to map script, but there's also there are also tools here for Landsat imagery, pre-processed orthos, other types. And that will lead you to this group in ArcGIS Online. So the landing page is pretty much the advertising. This is where you'll find the actual scripts. Want to dive deep into this topic, my boss Peter Becker wrote a very detailed paper on all these different concepts of the mosaic data set. And I think that's all I've got. Unfortunately, I've only got about 60 seconds left. I don't want to encroach on Thomas's time. Any questions while I shut down? I probably don't have time to show more. But any questions while I shut down and make room for Thomas? Yes.
I'm in the midst of working on a big data processing project, and I have 1,000 images to make it run.
Okay.
Or can I make it run? Will it survive on a machine that it could run on?
So the question is, what's the upper limit, the maximum number of images? I know we've done.
How do you calculate these images if you do?
Well, drone to map should be able to process your collection. 1,000 images you can do. I think we've done several thousand. I've got a few colleagues in the room. There's certainly going to be some upper limit, and you're going to want a very fast computer, a gaming system, a gaming computer with with a lot of cores and a lot of RAM will certainly help. I don't know what the max limit is, though. I don't know if we really have that number. So, yes.
Do you know much about the color color balancing in drone to map? When I've used drone to map for both just a stock camera on a Phantom, and then also we have a near infrared camera made by Centera for agricultural applications. When I do the drone to map, processing, I'm getting very different quality in terms of the color balance between images.
Right.
With the near infrared camera, there's a lot of beta thing, whereas with the stock camera from the Phantom, it's really good. I talked to Jordy about it a little bit. I don't know if there's a way to control those settings.
As far as the color adjustments, no. In the current version, I don't believe there's any way to adjust that. In ArcMap, you may be able to, and if you send me an email, I can continue the discussion. But I think the short answer, no. Okay. There aren't any controls for the color correction. Yes, one more while I make room for Thomas.
Is it that system that is managing so easily, like
mosaics and single frames, and it works only in ArcMap Online or also in the new version of ArcMap Pro. So it will be developed also in ArcMap Pro, or it is only working on online?
You mean drone to map, or do you mean ortho mapping?
Ortho mapping.
Ortho mapping will work. It's been running in ArcMap for some time. The challenge there is you've got to run individual geoprocessing tools, so you have to follow a workflow and know which tools to run in which order. In ArcGIS Pro, we've put that into a packaged workflow. The footnote about ortho mapping is it will generate the 2D products, but it does not generate a point cloud. So you're not going to get the point cloud or the 3D mesh, but you can generate the DSM and the ortho. Anyway, thank you. I want to be fair to Thomas. Send me an email if you have questions. I can leave my contact info with Wendy.
Greetings. Welcome to Open Drone Map, free and open source toolkit for creating aerial Ortho Mosaics. And we have here Thomas Holderness of the MIT Risk Lab. Thomas is a research scientist at the MIT Urban Risk Lab. We're in Ecuador Indonesia's disaster map project, head of ICANA, and develops geospatial solutions for analysis of extreme weather events. PhD in geomatics and is professionally accredited by the Royal Geographic Society. Open Drone Map is a free and open source toolkit for photogrammetric processing of aerial imagery captured by unmanned aircraft. It's really a tool chain for taking raw UAS imagery and moving it into a wide variety of. So that this is a very exciting topic, and so I'd like to introduce Thomas.
Thanks so much. It's great to be here. So yeah, I must thank the organizers. I can't see Wendy, she's hiding somewhere, for having me, for squeezing me in. So I'm going to talk about Open Drone Map, but I would really like to put it in the context of our current research. And we all appreciate the screen's not great, unfortunately, but I want to just put this in the context of the drone revolution. I believe that this 2-day seminar is. And I want to put this in the context of our work in Asia and rapidly urbanizing areas. And so, megacities, rapidly urbanizing areas, informal settlements on urban rural edges and peripheries cause us some problems as engineers and scientists when we start to think about the sustainability of those environments, when we think about the response of those environments to things like climate change and extreme weather events. So we're going to start with this map, which shows where everyone else lives. Everyone else lives in this circle, and the rest of us live in the rest of the world. Most of the people live here. And so that's kind of intriguing. And then within that circle, there are 20 megacities, 14 are sitting on river deltas, 18 have experienced flooding in the past decade. And so there are some significant challenges, like I said, particularly when we consider the precarity of the infrastructure within those urban environments. And so for the first time as researchers, those tools that are available to us in terms of small drones, UAVs, GoPros being fixed to those, allow us to capture some of the information about the precarity in a very qualitative manner to begin with. So this image, and I again apologize for the quality. This image shows a river called the Ciliwung River in the center of Jakarta, in the capital of Indonesia. And what we can see is the river flowing down the center of the image. So there's this brown. The water in Jakarta isn't blue; it's brown. Flows through the middle, and across the top we've got the one of the main railway stations, which is just here to your left of the image. Railway tracks running across, But then we have the railway bridge over the river, which abuts the original lock gate built by the Dutch in 1917. And you see another lock gate being built here. And so these gates were originally built to control the flow of water through Jakarta, because Jakarta is a city that experiences the monsoon and has a problem with flooding. This gate originally at the edge of the city, the southern extremity of the city, the rest of the city is spanning between here and the coast to the north. Now this is in the middle of the city, but it's still critical infrastructure in managing the flow of water through that city during those monsoon rains. And so this image is really exciting for us. We took it kind of early in the morning, and so not much going on apparently, but a really big, busy road as well to the left of the image. And so we can imagine that if there's a failure in this type of infrastructure within our urban environment, those failures can cause quite catastrophic problems. So the case of Jakarta specifically, Jakarta is a bowl which has rain falling in it, and it also has rain that comes down from the mountains during the monsoon season and fills up that bowl. About 20 to 30% of the city is now below sea level. The sea wall is as high as I am here today. And so all of that water must be moved through the city and managed. It's a human-controlled process. And so predictively understanding which areas need to be prepared for these flood conditions is a really significant challenge. Responding to the locations of critical infrastructure failure in real time to rescue those people, to set up shelters, to think about strengthening those levees is a critical problem. And so the last couple of years we've been running a project called Peta, which means disaster map, and we've been working with colleagues on the ground in Indonesia and here in the US to better understand how we can integrate different layers of geospatial information. The utility of crowdsourcing in this project, which is really our flagship data source. But today I want to talk about how we're going to integrate different types of data and some of the challenges that we pose to the UAV community in terms of understanding how we can better understand what was going on in that earlier image in a very qualitative. And I'll get to Open Drone Map in a minute. And so just a great slide showing this precarity of the city. The pink there, the city proper of Jakarta, population 14 million, the wider conurbation 28 million, which is the population of Australia in one mega city. Downstream flow, the blue areas to the north are +4 to -4 below sea level. And so during the monsoon, through this project, this collaboration, we have all of these different reports coming into our system of people confirming that flooding is happening in this place and time. And this data is used by the Emergency Management Agency to see and visualize and understand in real time human operators tagging those areas and saying, yeah, this is flood affected, we need to dispatch some boats, we need to dispatch an emergency pump, we need to open the shelter. And so this is an image that was sent to us as part of one of the reports that we mapped this year. This all happens in real time. But we're now, and I think this is very applicable to some of the work that we saw earlier and talked about in today's earlier presentations in terms of imagery. That term loosely, but as a service, and this service is provided by Amazon Web Services, lets us send off our image into their black box. We don't really know how their neural network works, but we send this image off to the black box and it comes back with a probability of how likely it is that the water is within that image. And so we can start to see how, when we're collecting these thousands of images from residents in real time, how can we understand computationally what's within those images, as well as displaying them and visualizing them through a design methodology so that people can make better decisions. Because at the end of the day, we want everyone to be able to make better decisions. Better decisions in real time. Should I go there? Should I go here? Is my house likely to be flooded? Better decisions long term. How do we improve the fragility and the resilience of our urban environment? As a remote sensor, I previously was like, great, let's get some satellites. Let's see what's going on. I failed to understand before I visited was the level of resolution in which people live their daily lives. This photo was showing a main street which is flooded, but the main street is only a couple of meters wide. Many people often build out porches projected from their houses. So we're thinking about a resolution of imagery which is just not available from satellite data. And so over the past year, we had a guy called Frank Sedler with our field team in Jakarta to understand how we could use different types of sensors, including drones, to capture some more information about this urban environment. And we were lucky to have Frank join us as part of this Fulbright scholarship. And so what we can do is now we can start to do really rapid surveys of some of the hydrological and hydraulic infrastructure to understand the conditions of the city. So we're not at the point where measurements can be made yet, but I think with some of certainly the previous presentation in terms of real-time image analysis, this data could be really powerfully much more better understood within the context. So what we're looking at here is one of the pumping stations in the north of Jakarta that pumps the water over the seawall. This image is getting darker. No, it's the bulb going. Okay, so the roof. You have to just believe me. The roof of this thing is a pumping station. The 4 huge pumps. These pipes are this big, pumping water over the seawall. This is an old pumping station here. It exploded a few years ago because it was running at 120% capacity to get out all of that water. And so what we can do is, this is really interesting because it just gives us a perspective out into Jakarta, some of the land reclamation, of the new builds that are happening out there in the ocean, effectively. And so now we start to move the image to be on Nadir, and we start to be able to think about how do we get elevation data? How do we start to map this environment? How do we use this imagery to collect information about Jakarta? But more importantly than that, rather than us, we were lucky to have Frank, and he's an excellent surveyor and knows a lot about drone technology and lots of flights. But rather than having to send Frank to map all of Jakarta, other 500 drone users that we know about that are all residents, who are all non-geospatial experts. What about the government agencies that have started to purchase drones, but the GIS team doesn't necessarily have the resources available to them to do large-scale image processing because they're stretched? Enter stage left, open drone map. So OpenDroneMap is a open source toolkit for aerial imagery. It was originally developed by a team at Cleveland Metro Parks who are still well involved in the project, leading the development. And they developed it because they realized that they were collecting lots of imagery for their wetland mapping. And they do a lot of invasive species and also environmental monitoring. They have some really tough environments to go and survey manually. And so they use a system of kites and balloons and UAVs to collect imagery and to gather information and map those environments. And so they realized they were gaining more and more imagery, but what software was available to them at the time that wasn't prohibitively expensive, that was open source within their ethos that they could use. And so they bit the bullet and they started OpenDroneMap. So it's modern photogrammetric processing software. We have fully automated matching. We can produce digital surface models, and we can do image mosaicing. OpenDroneMap uses a structure from motion process, and the thing that I'm most excited about is the latest developments in ortho photo generation. So I'm really glad that someone already explained structure from motion, because my photogrammetry is pretty rusty. And so you can't actually see I don't think you can see the lines on the screen, but it was already explained in the previous presentation. We have images that have overlap, but also that we can identify similar points. And so this allows us to produce there we go. So see those data. So we identify common points in the images. And we can produce a point cloud from that. And so we've got point clouds. If you have ground control, then we can start to understand an elevation from those point clouds. And we can, in the latest iteration of the software, we've now got dense point cloud development, which allows us to then produce a mesh. So we use the point cloud library and then mesh discrimination process. So you can produce this mesh moving also on to 2.5D at the moment, which allows us then to have textured images. So now we've got a product that allows us to see both the images as they were from above on Nadir, but also to start to think about interrogating that environment and asking questions of it, understanding what's going on. And then finally, the most kind of interesting project from my perspective, ortho photo generation. So, fantastic bit of kit that was developed in the last couple of years, open source. You can download it, source code is all available. But have to admit that the code was all over the place. It was a series of pieces of code that were glued together with a Python library, and that isn't really accessible. I found it tricky to set up and use, so it's certainly not going to be accessible to anyone else in Jakarta that we're trying to bring on board as a community effort to start to map the city. And so we started a project to develop a web-based interface. By the time we started this project and we had our first meeting and we had a grant, which I can talk about in a second, by the time that we had sat down all together and got everyone organized, the community had already produced this, which is called Web-Based Open Drone Map, which is an amazing initiative which provides through a Node.js server a web-based interface for project-based operations on those images. So all of those previous steps that I just showed you, you can operate from this web-based interface. It's not currently hosted, so you still have to download and set up hosting yourself, but there are instructions online. But the amazing thing about it is you can upload your imagery, set those metadata records as you like if you have ground control points, and at the end you get a Slippy map product, web-based map. And so for this, for us, this is really a fantastic leap forward in terms of the ability of us to provide a service for other people. Essentially, we start to think about the opportunities for an Instagram of drone imagery. The drone shop in Jakarta is always empty. As soon as the drones come in, there is a queue out of the door of people buying the next set of drones. I just can't overstate the excitement and the number of people in the regular population who are now very excited to be flying their drones, organizing themselves into clubs, starting to put cameras on their drones and thinking about mapping. I think the question and the challenge becomes how do we tap into that and how do we make it easy and how do we break out of our traditional GIS paradigm in terms of you need to do these steps to process your imagery. You need a computationally equipped computer with expensive graphics cards to be able to do that. Of course, we're not really solving the problem, we're just moving it, and we move it to the cloud. And so some work by a colleague of mine, Matthew Berryman, I like to just show his tweets and slides. This one, there's nothing more boring than a photo of a server, but I thought I'd put it in, at least reminds me to talk about it. So he's been working with the National Computing Infrastructure Unit in Australia, which is a resource available to researchers within Australia, looking at how we could use that kind of, it's not really HPC or high performance computing, but more of a cloud-based architecture behind Web Open Drone Map to provide a very scalable interface where anyone could go in and upload their imagery, and then we, as the researchers, would take on the processing of that. Okay, great. So I just want to talk through a couple of the latest developments and show some of the outputs. Unfortunately, we haven't yet got to the point where we've processed any of the data that we've captured in Jakarta. It's still in the works, but the Center for Applied Geospatial Analysis at NCSU through Stephen up in Cleveland have been kind enough to share some of their derived products, so we can get to point clouds. So we get to point clouds, and then this is really exciting. So now getting to DTM extraction from the imagery. And so gluing all of this together now, all of the different streams of Open Drone Map are coming together. The organization is available on GitHub, so you can see all of the different modules that are available, and they're all slowly talking to each other. And so latest developments, 2.5D meshes for better ortho photos. We've got test flights scheduled for spring 2017. If anyone has imagery they would like to also to contribute to be sample data or sample test imagery as part of the Open Drone Map effort, that would be great. And so we're going to test Open Drone Map against its commercial competitors to see where our strengths and where our weaknesses lie. And then actually just 2 days ago, version 0.3, the branch has been merged on GitHub, and so we've got large TIFF support. DTM generation is now in the stack, improved texturing and much more. I encourage you, if you're really interested in of a technical mind, to check out the slides. I know you can't see the link right now, but they'll be available afterwards. And you can click on that link and it'll take you to the whole action on GitHub. And so then thinking to the future, what does the future of an open drone map hold, and how does it bear, how as researchers do we come to take this to use? So I think there are obviously some really exciting technical challenges to overcome, and I think that there's some really clever people in the community and researchers that are working on this. But I think one of the really interesting things for me is making this much more accessible, making the products really tangible for people at the end. And the project's come such a long way in the last couple of years since I first saw it presented. Taking OpenDroneMap and allowing it to integrate with other projects like OpenAerialMap. Those of you, I don't know if those of you have seen that, but allows you to, they're essentially trying to be the OpenStreetMap of airborne data, which is a really exciting project. And so really, I think that the opportunity becomes, drones are all around us. Now there's a huge elephant in the room that I haven't talked about at all, and that's legislation and whether you can fly. Things are very different in Indonesia than the US, and things are very different in Australia and New Zealand again. And so there are some challenges there of informing the community about when you can fly and how you can fly and what's legal and what's not. But I think the ability to say to a community of non-specialists, hey, you've got this drone, you've invested in it now, it's fine for you to be racing in the park, but maybe you would be interested in doing this, capturing this data, contributing it. Where are the pumps near you? Where are the canal walls? What's the profile of that river look like during the dry season when there's no water in it? And so that's kind of something that we're working on at the moment. It's kind of unfortunately been pushed to the back burner whilst we've been focusing on some of the more, solving some of the more technical challenges. Web ODM is an amazing testament to what the open source community can do. And so, yeah, I think I'll probably leave it there, and then we've got time for questions. Okay, great, you can read the pink, so the presentation will be online as well afterwards. Thanks very much. Great, well that was easy. I'll bow out then. Last call for questions before I sit down. Yeah.
So this is citizen science going on in Indonesia, and I'm just wondering, is there a need to manage these? Are they, you know, is it an anarchist accord? Are they sharing? Or, you know, are they crashing into each other? Any of the above?
My take on it is that there are already some very well-informed and well-organized groups that are leading the way. Our work in Jakarta as a whole, not just on crowdsourcing, has already shown that communities are incredibly resilient, particularly when they have an organization in there that's leading them through that process, whatever that, if that's land tenure rights, through to we should report flooding, through to we should put rope lines in. Those organizations are now starting to look at geospatial data much more seriously. There's a lot of investment. Organizations like the World Bank doing a lot with the Humanitarian OpenStreetMap team there. But there are some fascinating challenges of, so for example, we asked a community to map their neighborhood. And we just did it on paper. We use field papers, which allows you to print out OpenStreetMap. Of course, on OpenStreetMap, their informal settlement was just a gray swath. There was no data there. But we asked them to map it with the view that we may then come along and fly it. And we actually took some flights because they are adjacent to one of the meanders in the river that floods every year. And of course, when you then take that data and geo-rectify it, the main street in people's minds is about as wide as this room. In reality, it's between my two arms. And so then all of a sudden you have this fantastic data, which is great quantitatively, but qualitatively, but we couldn't use it, we couldn't add that data to OpenStreetMap directly. But the drone would allow us to capture some of that data over the top and also see the interface between the river, which the government has now heightened the levy. So I think it's not completely random. There's a lot going on in that space already. Indonesia as a whole is very supportive and really all about open data. So OpenStreetMap is the base map for every city in Indonesia now. So every government map that you see is overlaid on OpenStreetMap. And the governments are starting to feed back into OpenStreetMap as well. And so I think this interplay with OpenAerialMap as well will lead that. It's not just individuals, people are really already in those networks, I think.
Just as a quick follow-on, do you have any information about whether these are young adults, are they children in school, or are there schools involved? Is it boys versus girls?
Not off the top of my head. Anecdotally, we know that it tends to be young men, technologically interested and engaged. I haven't seen any examples of schools being involved directly. Tends to be students to university. Indonesia have been quite supportive. They've been quite interested as well. They've got lots of young students that are interested. So Yeah, well, that's an interesting question. We've talked a lot about how to galvanize those sectors of society to get them to be kind of more engaged rather than being random. I don't have a clear answer for you yet.
Thank you.
So one other, I think this is a great project you guys have put together. So one question I have is, there's so many more applications that this could be used for, like destruction of World Heritage sites around the world. And I think the fact that you're kind of leveraging an open source and community outreach platform lends a lot of power. Do you have any kind of future ideas on where you want to see this project go?
Yes, infrastructure.
Okay.
I want people to map the infrastructure. So there's an incredible discord between what the government thinks the infrastructure is currently doing and what it in reality it's doing, and its status and whether it works and is it broken. And this photo of the canal wall, the levee that's collapsed that I showed earlier on, no one from the government had that image at that time. Someone had obviously got there because they put tape around it, but then it's not, that data isn't necessarily recorded. And so then when you come back to do like event reconstruction of like, why was the flood in this neighborhood? Like the pump was on, the canal was good, like why were these people suddenly flooded? So all of a sudden becomes a near impossible task to, and as you go and interview everyone on the ground, to understand what conditions caused that event to happen. It's very, like there's no basically data flow within the infrastructure management of like this thing collapsed, so we should go and fix it. And I think that imagery both on the ground but also from the air, like in the pumping station example, offer a really, really strong way for people to capture the current status of the infrastructure, where it's at, what it's doing. There are some pretty grim examples where the things just have been built and then they're just kind of crumbling. One of the communities we worked with this year was flooded because the levee was built and then it rained in the village and then the water couldn't get into the river. So there was like, we built the flood wall, the flooding is going to be great, like flooding for you guys, the river's going to stay in the river, and then they flooded it. And so capturing that and the spatial extent of that information is really like, that could be done with a drone within a couple of hours, because we're only talking about small areas each time. It's a big city, but it's pockets, and it's like that spatial disaggregation is a challenge. Thanks so much. That was great.
Just log in the browser. I can just put it. I was gonna go. Yeah, I'm using Google Slides. If I log into my Gmail and log issue. I log into my Gmail and log issue.
Welcome to PM drone applications at the Harvard Humanitarian Initiative. This is Fane Greenwood, research there at HHI, focusing on ways that UAVs and satellite technology can be used in humanitarian contexts. She's an instructor in the Signal Program's Remote Sensing for Humanitarian Program workshop, and is especially interested in developing ethical and technical standards for integrating drone technology into disaster response. Fane, in this presentation, will provide an overview of the way drones are being used internationally in the humanitarian and development sectors, and will be putting particular emphasis on ethical issues.
Sorry, I'm just logging into my Google account. Here's the presentation. You just. Yeah, it's not getting a signal. Worked. Okay. Go full screen. All right. After that minor technical issue, my name is Faye Greenwood. I'm with the Harvard Humanitarian Initiative Signal Program, and I work on the humanitarian applications of drone technology. I'm also a drone hobbyist. I own them, I fly them, I have a lot of fun with them, and I'm really interested in how the democratization of drone technology can have a positive impact on humanitarian aid around the world. What I want to do is talk briefly about what the Signal program does. I want to devote most of this presentation to giving you a general sense of what's being done in humanitarian aid work with drones around the world, and what some of the key ethical and operational challenges to that work are. So, without further ado, so as you may have noticed, in the past few years, drones have gone from relative obscurity to being something that you see everywhere. They've gone from a technology that no one knew about to something that your obnoxious neighbor flies over your house. They're being used around the world for a wide variety of applications. I mean, there's many of them, everything from agriculture to search and rescue to media work, you name it, drones are being used for it. We're going to focus here on humanitarian aid work. And also, admittedly, I will also say that in this context of this presentation, I'm using humanitarian in a pretty fast and loose way. I'm including things that one might say are also included under development, but So, to give you a sense of what is a humanitarian? Well, it turns out that's kind of an amorphous thing, but one could say that a humanitarian is someone who's doing work that adheres to the humanitarian principles as defined by the International Committee of the Red Cross. These 4 humanitarian principles are humanity, which is human suffering must be addressed wherever it is found. The purpose of this action to protect life. Does that work better? Okay. The purpose of humanitarian action is to protect life and health and ensure respect for human beings. Neutrality, humanitarian actors must not take sides in hostilities. Impartiality, humanitarian action must be carried out on the basis of need alone. You don't prioritize anybody over anybody else. And operational independence. Humanitarian action must be autonomous from the political, economic, military, and other objectives that any actors might have. And humanitarian aid addresses humanitarian disasters. Some useful definitions of what a humanitarian disaster is: when human, physical, economic, or environmental damage from an event or series of events overwhelms communities' capacity to cope. That's from World Vision International. Humanitarian emergency is an event or series of events that represent a critical threat to the health, safety, security, well-being of a community or other large group of people, usually over a wide area. And a complex emergency is what happens when you have a considerable breakdown of authority in some area for internal or external conflict, which requires a major international response. And these may include situations where you've got a natural disaster and a conflict in the same place. And a lot of the work we do at the Signal program focuses on ethical issues. And that's something we are very passionate about. We think that we have a good niche in focusing on. Some of these key questions include, and I'm going to talk more about this tomorrow, but how do we protect the privacy of people being photographed from a drone? What should we do about drone data that might be used to harm innocent parties? What do we do if we crash a drone? What do we do if it harms somebody? Is there a redress or rectification process? How do we inform communities what we're doing? How do we involve them in the process? How do we avoid engaging in acts of data colonialism, where we're taking people's data without really explaining why or what we're using it for, which is a real concern in many areas? And are we flying the drone because we want to and because flying drones is cool, or because communities can actually benefit from the data because we're actually helping people to recover from disaster? So to achieve, to mitigate these ethical problems, a number of organizations are working on developing ethical codes of conduct, ethical parameters that drone operators should follow. So these include our organization, the Signal Program, Humanitarian UAV Network, UAVators, are two big players, or two people that have done a lot of work in this space. And humanitarians, obviously, are people, and then humanitarian, again, includes anybody who engages in these, who adheres to the humanitarian principles. That could theoretically be you and me. Humanitarians need to consider what they want these standards to look like. Do we need a SPEAR handbook, just a handbook, basically outlining minimum technical standards and ethical standards, humanitarian work? We need something like that for remote sensing and drones. And how can key stakeholders work together to create these standards? A license or a badge for approval for you to use a drone in humanitarian contexts. And who would humanitarian UAV operators answer to if they messed up or did something unethical? These are all unresolved questions at this point. They're really interesting. So to give you a sense of what we do, so this Signal code is something we're really proud of. We worked on this for quite a lot of last year, or at least early this year. And what it does, the Signal code, which is a 100-page document you can download online, identifies 5 rights all people have related to information during crisis, and they are applicable to the use of UAVs in crisis situations. And the origin of this is that we realized that if we wanted to create a code of conduct for the use of drones, we needed something that was broader. We needed to develop a code of conduct. We need to develop a rights-based approach to the ethical use of all kinds of information technologies during disaster. And that's where this came from. And the 5 rights are the right to information, the right to have information on what's going on around you, the right to have information about your status, which is really important. I mean, we're seeing a lot of refugees coming out of other war-torn areas. They're having mobile phones, and they're really prioritizing having access to information. They're prioritizing their mobile phones over just about anything else. That information allows them to survive and to protect themselves. The right to protection from harm, the right to be protected from, and this would include harms from data. The right to data security and privacy. People should be able to expect their data should be kept secure. They should expect to have some privacy. They should expect their data should not be shared willy-nilly. The right to data agency. People should have the right to have agency over what's done with their data, what it's used for. And the right to redress and rectification. If something bad is done to an individual or a group of people with data, they should have the right to some kind of redress, redress of some kind, and rectification, the correction of that. And these rights are based on a lot of research we did based on other IHL, International Humanitarian Law, a lot of prior humanitarian precedents, the Universal Declaration of Human Rights, and European data safety and data privacy precedents. That's where this came from. And something else we're hoping to do in the near future is that we're hoping to conduct case study research on drone deployments. That would include stuff like what Daniel Dunn's doing in Vermont, and also research in other countries. So our first case study hopefully will be on Nepal. There was a huge earthquake in Nepal in 2015. We'll talk a little bit more about that in a second. And a lot of people with drones came out to respond to that. They had good intentions, but the drone deployment, as many will agree, was kind of a mess. And what we're hoping to do is go out there and assess that, talk to people on the ground who were there, talk to the drone operators, talk to police and military, and just develop a holistic case study of what happened. Kind of explain, and then hopefully develop a methodology for assessing other drone deployments and evaluating if these drone deployments really had the impact on these communities, the positive impact that we hope they did. So that's something that we're hoping to do and hoping to formalize. And anyway, so that's in essence what we're hoping to do with the Signal program in the next year or so, along with our educational offering we'll talk about in a second. But it's the brief history of drones. I'm probably going to skip over this real quick. Here's a point that I really like to make when I'm talking about humanitarian drones. Some people assume that all drones are linked to the military. They assume that drone technology, the consumer drones we're talking about largely in this presentation, in this conference, are all developed in military technology. That's actually not true. The origin point of consumer drones, they're essentially flying mobile phones. They're like flying phones. And they did not originate with the military. There's no evolutionary chain of progression from the Reaper UAS to a Phantom drone. They have different origins, and it really is not accurate to say that all UAS, including civilian UAS, are linked to the military. And large UAVs designed for military use, like the Celix EX Falco, this image, have occasionally been used for humanitarian monitoring purposes. These are really rare occasions. These things are incredibly expensive to operate, to purchase. So that's a distinction I like to make. And these are some key questions that potential drone operators should ask themselves before they start flying. I think this is part of a really essential process of pre-planning and pre-mission planning. These might include, what's the need that requires the drone? What are the rights of the population when that need is demonstrated? What are our protection responsibilities, again, to protect people from harm? And how do we differentiate the UAV from similar devices that are being used by other actors in this context? How do we set, manage, evaluate, and communicate expectations? How do we help the community realize what we're doing, what's possible, what's not possible? That's a really important aspect of this. And this is some more info on humanitarianism. I'll put this on the internet if you're interested in learning more about the academic and operational role of humanitarian aid work. And why are drones being used in aid? Why are we seeing so much more of this than we have in recent years? Well, again, as most of you know in this audience, drone tech is not new. RC aircraft have a long history. Autonomous aircraft have a pretty long history, or semi-autonomous aircraft. And low-price sensors, miniature computers, and batteries designed for smartphones make consumer drones possible. Humanitarian aid development workers have taken advantage of the fact that drones are become ever more cheap and easy to use, start experimenting with them. You give this presentation to some audiences who are not super familiar with drones, and we'll skip over part of this. But the advantages of a civilian drone there's a few of them. The advantages are, this is in comparison to other remote sensing technologies like satellites and manned aircraft. They're often way less expensive. They're often easier to learn how to fly. They can fly under cloud cover and at low altitudes, and they can capture more detailed images than satellites can in many cases. Finally, flights can be repeated constantly. You can repeat a flight as many times as you like. And whereas with a satellite, you might only be able to shoot images once a day. Of course, there's a lot of drawbacks. The legal status remains unsettled in many places. You still have to get close to the subject, and that could be a problem in a war zone. Drones can be shot down, stolen, or compromised. The data can be taken from the drone. And they, of course, create other privacy and safety concerns that you just don't see with manned aircraft or with satellites. And of course, drones are valuable because of what drones can produce, the data that drones can gather. And these include videos up to 4K quality, still images, NDVI, neutral density vegetation index images, thermal images, 3D models, orthorectified maps, digital terrain models, and much, much more. You, of course, saw some great examples of all this in the prior presentations. Humanitarian UAV uses, and these are, again, humanitarian uses, I'm using it kind of broadly here. But post-disaster mapping, pre-disaster mapping, disaster risk assessment, agriculture, conflict monitoring, land rights and surveying, communications, advocacy, epidemiological research on the spread of disease and other public health concerns, and delivery, and more. So again, drone mapping, this is a basic overview of drone mapping. I would say that in the humanitarian aid world, mapping is by far the most common and most proven to be useful area. I'll talk about delivery in a minute. And here's some great examples I'd like to bring up. And Tomas, I think your example from Indonesia was a really great example of what can be done in the urban area. This is another one. Since 2013, the Dar es Salaam City Council has worked with the World Bank and other partners to map flood-prone slum areas with UAVs. And so the Dar Ramani Hurios, which translates into open mapping, trains university students, community members to use OpenStreetMap to map the neighborhoods. What they do is they use the drone to create high-resolution imagery of these slum areas and gets community members together to create much more high-quality maps than they previously had. And the same imagery is also used to create flood risk models. And it's really interesting to see what's happening with this. It seems like drones might be a great solution to map temporary settlements. For example, the city of Ulaanbaatar in Mongolia has seen rapid urban expansion the past few years. A lot of nomadic people will also come in on a seasonal basis, and they've been using drones to map these temporary communities and these quickly growing communities that can provide services. And I think it's a really fascinating application. And another example, in the Maldives, UNDP is working with drone maker DJI to use drones to make 3D maps of vulnerable villages and islands. The data will be used to create risk maps in advance of sea level rises due to climate change. And again, drones are inexpensive, they lower the barrier to entry for map makers, and it's possible we'll see a lot more of this in the future as climate change becomes a more and more important and a key problem. We'll also see more people using drones to make climate change risk maps. And here's a brief video which I'll show you. I thought it was cool. Can I have volume on this?
Sound is not coming.
So with the help of drones, what we are trying to do is collect some of these data, such as how the topography of the island is changing. We want to enhance the capacity of community emergency response team to be better prepared during a disaster.
For me, what's most striking is the topography of the island. This is usually the side where the island will experience surges during the monsoon. For response, it's very important for us to get a visual image of how the island actually looks like.
It's part of there, but if you want to see the rest of the video, I'll put these online. And post-disaster mapping is perhaps the best known current use of drones in humanitarian work, but you probably heard about. There's a lot of recent examples: Ecuador Earthquake 2016, Nepal Earthquake 2015, the Vanuatu Typhoon in 2015, with Signal worked on interpreting imagery from, and Haiti, Typhoon Haiyan, you name it. There's been a lot of interesting applications of this. And this would be a good time to mention the Humanitarian OpenStreetMap team, which applies the principles of open source and open data sharing humanitarian response to economic development. And the idea is to use teams of volunteer mappers to make maps, and immediately after disaster, they were deployed in Nepal, and deployed in many instances. And an associated project is the Open Aerial Map, which is a set of tools for searching, sharing, using openly licensed satellite and unmanned aerial vehicle UAV imagery, especially for disaster, which again is correlated with with the project that Tomas was talking about, Open Drone Map, or hopefully will be used with in the near future to create a fully open solution. And again, to go back to the Nepal earthquake, this really was kind of the coming out party for humanitarian drones. A lot of organizations deployed, and a lot of organizations, at least 15, and a number of groups and individuals use drones for all kinds of applications, from post-disaster reporting to surveying, search and rescue activities to mapping, garnering considerable media attention. Not all the attention was positive. In May 2015, the authorities in Nepal banned drone flights without explicit permission, citing the potential misuse of sensitive information. And this is a real pitfall or potential problem for drone mappers working in countries that may not have drone regulations in place. If you do something that the authorities don't like, or you fail to liaison with the authorities, you could really incentivize those countries to introduce harsh new drone restrictions that will then impact people who are from or live in those countries who might want to use drones as well. And that's a really important point that people using drones for humanitarian purposes really need to keep in mind. Let's skip this one. And the Ecuador earthquake, again, happened in April 2016. It killed at least 661 people, injured over 27,000 people. Local drone operators were able to collect post-disaster imagery, which was made publicly available on the Open Aerial Map website. And imagery is now being used by Humanitarian OpenStreetMap as part of its post-disaster mapping efforts. And this also brings me another point. There usually are local drone operators. People often assume here in the United States that in other countries, they won't have drones. The fact of the matter is, in my experience, pretty much every country I've ever been to or worked in or heard about has at least one person who's a drone nerd. In Cambodia, I can think of a few dozen Cambodians who build and fly drones. I used to live there. And in Niger, there's a guy from Niger who knows how to build and fly drones, using them for refugee camp management. There's usually somebody in each country who knows how to do this stuff. You don't necessarily need to import people. So another application is search and rescue. Drones are being used at a number of locations in these preliminary experiments with search and rescue. China's National Earthquake Response Support Service has been using drones for quite a while now. Disaster data to monitoring centers that look for missing people. Drones were recently used, as in like last month, a major search operation at the Grand Canyon of the National Park Service. A woman, I think, jumped over the edge, and they used the drone to find her body. They've also used drones to look for a car that went off the rim a few months ago. That's an interesting new application. And again, numerous agencies are experimenting with this. There's a lot happening in this sector. Food aid is a huge thing, and drones can be used in a number of ways. They can be used to inexpensively assess crop damage from disaster, which is this is being done in India. Drones are being used to assess damage from things like hailstorms are a big problem in parts of India. They take out crops, and insurance adjusters need to know how much damage there was so they can pay them out. The Indian government is experimenting with a pilot project to use drones for this. They can also be used to monitor crops and increase crop yields in places that have are difficult to farm in, or in areas that have poor water supplies. They can be used to make farming more efficient. And they can also be used to detect crop disease early, to spray crops more safely, and also to survey for new farm construction in a much more inexpensive way than was possible in the past. And also mapping watersheds and even locating locust populations. There's some pilot work being done to use drones to identify where locusts are breeding. Conflict monitoring is another interesting and controversial application. In January 2013, the United States nations deployed these Celex Falco surveillance UAVs. I showed the picture, they're really large, to Kivu province for deterrence and surveillance purposes. These were basically medium-range UAVs that were able to do long-term monitoring of areas with militias. And UN peacekeepers have since deployed these surveillance UAVs in Mali and in the Central African Republic. And the UN Security Council approved the use of UAVs for this purpose in South Sudan in December 2015, but the government in Juba opposed the measure, and insofar as I'm aware, they have not been deployed. And it's a controversial application because obviously they're assisting peacekeepers. These are large UAVs, they're not operated by a single individual or group of individuals. It's an interesting application. Population movement and refugee camp management is another thing we're seeing quite a bit of. And drones can be used to monitor and map refugee camps. They're temporary settlements. They have a lot of infrastructure issues, water, sewage, and drones are really provided cheaper, easier ways to get real-time data on how these refugee camps are expanding. This is either not possible or prohibitively expensive with satellites and manned aircraft. And as I mentioned, there's a Nigerian drone maker who's working with UNHCR. He's he built his own inexpensive drones, and he uses them to capture video and still images that can be used to map these settlements. And I'm really interested in this application. I'm hoping we'll see more of it in the future. Land rights and surveying, you'll hear more of that from Walter Volkman, who's speaking tomorrow. But drones make it quite easy and inexpensive to make cadastral maps. And that's really important in areas that have suffered from conflict. Often in a conflict, cadastral maps to show who owned what land are destroyed. And then there's a great need for detailed, high-quality maps that indicate who owns what property. So cadastral surveying has been done in Kosovo and Albania, sponsored by the World Bank. And we also see land rights issues are a big problem as well for people in Indonesia and Guyana. Indigenous people have been using drones, inexpensive, homemade DIY drones, to map their land and use them to prove that companies are illegally logging or illegally mining in their territories. And the Dayak people in Borneo actually use drone imagery to win a court case against a logging company, which is pretty amazing. And there's a little more on the Dayaks and Drones project. I think it's fantastic. Aaron Darajwali, who spearheaded that, is a friend of ours and is a fantastic person. I really advise you to check out his work and to watch the DIACs and drones video. If you search for it, you'll find, search DIACs and drones, you'll find it. His work is fantastic. He is, insofar as I'm aware, in Papua now, working on a similar project to help indigenous people there use drones to document deforestation and mining, illegal mining. So keep an eye on his work. And this is a little more about the Cadastral Surveying Project in Kosovo. It happened in 2015. Specialists at the World Bank Innovation Lab used a SenseFlight EP drone, which is a fixed-wing UAV and can fly for quite a long time. Completed a one-week cadastral mapping activity, and they were used across the cadastral reconstruction after the war. And they're actually helping women who are particularly vulnerable to having their land rights, losing their land rights. They're helping women secure their land rights. And Walter Volkman has done similar work in Albania. And I used to be a journalist. This is close to my heart, but drones have been used for journalism advocacy for quite a while, since 2013 at least. And they're valuable if they permit reporters to get an aerial perspective on sensitive events and topics. Examples of this work are legion, but some great good ones include footage of refugee movement on the border in Slovenia and Croatia, footage of damage to Palmyra by ISIS, a route protest from 2015, a more recent example, activists and protesters at the Dakota area pipeline were using drones to document the police using water cannons on them. They were using drones basically watch the police responders. And a number of these protesters flying drones had their drone shot out of the sky by police, which is not, I actually read an article last month for Drone 360 magazine on incidences of drones being shot out of the sky. It's incredibly dangerous, don't do it. But it brings up interesting questions about how drones can be used by little guys, quote unquote, by people who do not have a lot of institutional power or money can use drones to gather information that they can't gather any other way. And I find that really interesting. Epidemiological research is yet another new application of drones for humanitarian-esque purposes. The London School of Hygiene and Tropical Medicine recently used UAV images to study links between environmental factors and malaria transmission in Malaysia. What they did was they used the maps to figure out where places where monkeys carried this, or tracked this kind of mosquito that carried this malaria strain. Figured out where monkeys are most likely to overlap with human settlements, and we're able to use that to kind of evaluate the links between these diseases. Brazil used drones recently to search for a mosquito breeding location in the cities to counteract Zika. And in Sri Lanka, researchers are using UAV imagery to look for wells that may carry infected water to stop the spread of this emergent disease called CKDU. Everyone's favorite topic is delivery drones. It's not my favorite topic because I think drone data is way more interesting than drone delivery, and explicably gets far more attention. However, UAV delivery is a nascent field. There's a lot of technological regulatory challenges to making drone delivery work. I'm sure it will work at some point in the future, but it's not there yet. Some of these challenges include creating air traffic control systems that work for both drone and manned aircraft, deploying sensitive avoiding technology that can navigate unexpected obstacles like dogs, lawn flamingos, whatever. Solving infrastructure and security challenges. I mean, what's stopping me from shooting down your drone that's carrying your Amazon package? What's stopping you from grabbing it? There's a lot of unresolved issues there. The one example of testing and experimentation that's being done in this area is UNICEF Malawi is working on to create a humanitarian drone testing corridor. And they're hoping to use transport blood samples for HIV testing in this specialized corridor. And similar efforts are being undertaken in Rwanda. And I've got learning out of time. I do want to mention at the Harvard Humanitarian Initiative, the Signal program will be hosting a remote sensing for humanitarians workshop in June of 2017. And insofar, it's the first professional training course providing humanitarian professionals and others who don't need to be a humanitarian professional take this course. The basic skills and knowledge required to use remote sensing in their work. So that includes satellite and drone imagery and data management, data security issues. And we also run a simulation on the last day. We're having the Naval War College help us develop a new iteration of this tabletop simulation of a humanitarian disaster using remote sensing, which we're excited about. We hope that the course will equip students with expertise needed to manage, design, and utilize remote sensing in natural disasters and conflicts. And it's going to be happening from June 26th to 30th right here at Harvard. I'd be happy to give you more information on that if you're interested, and we'd love to see you. And how much time do I have?
About 7 minutes over.
Well, you know what, we'll quickly go over the key barriers to wider drone use. These include regulatory environment, it's so complicated. Many countries do not even have regulations on drones yet. In other countries, regulatory environment is very unclear, unstable. The public mistrusts drones. If you own a drone, you're probably aware that people are often very hostile to them or don't like them, don't like the idea of them. That's a barrier that we need to overcome. We need to make people realize, we need to help people realize that drones are not necessarily always bad. Identification and differentiation. How can you tell who's flying a drone, what their intentions are? In the early days of the Red Cross, they realized that raising a big Red Cross inside a hospital is less likely for them to be blown up. And when it comes to a drone, you've got a bigger problem. They're hard to see. It's hard to tell what they're for. And also, everyone from ISIS to humanitarians to journalists are using the same consumer drones. So we need to find ways to differentiate them in the sky. Privacy issues, again, how are you storing your drone data? How long are you storing it for? What data should you collect? Property issues. Should you be able to fly a drone over private property? Under what circumstances? And again, airspace sharing issues. But I think I'm going to stop there and see if anybody has any questions for me on humanitarian UAV usage. So, questions? Yes.
I have one. Is there any sort of, so I'm at Tufts University, our students, it's very international, right? Places. And we're doing mapping work all over the world. Is there any sort of resource guides around like use restrictions that someone's kind of bringing together a bit in different parts of the world, different countries, or subnationally? Anything like that? I've always wanted something like that for GPS as well.
Yes, there are. So there's 2 places you can go. FSC, which is a Swiss NGO, developed a drone regulations database. And that came out last year, so I believe it's being updated quite regularly. I also produced an international drone regulations database in 2015, and I was working with the New America Foundation in DC. That's still active and can be found at drones.newamerica.org. So those are 2 resources that should give you a sense of what international drone regulations are. Yeah, always check in advance before you go anywhere. I would also advise you to get in touch with local drone users, because they'll have the best sense of what's going on regulatory-wise than anybody else. You can find them on Facebook or Twitter. It's usually pretty easy. Any other questions? Okay. Oh, and there will be a reception outside. We will have, we should have refreshments, and please join us outside, and we can mingle. Thanks.
Thank you.